only know side information. So the main thing here is that you only know 3 sides. You have no angle info, meaning you don't know anything about the angles other than the 90 degree. Obviously, it's a right triangle, it's got 90 degrees, but the problem is mostly going to look like this, where you're trying to find a missing side, something like that. That is Pythagorean theorem. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. On a problem like this, you don't want to use law of sines, law of cosines. Just use Pythagorean theorem. It's a lot faster. Anytime you're just trying to find sides, it's Pythagorean theorem. Next is when to use SOHCAHTOA. So anytime I'm using trig, I should be looking for, again, a right triangle. So SOHCAHTOA is used for right triangles. It's got to be a right triangle. I can't have a hypotenuse if I don't have a right angle. Okay. The information involving trig, you should be looking for information with 1 angle and 2 sides. So as far as the angles are concerned in these problems, my angles, but when I say 1 angle, I mean the angle other than just the 90. So I'm basically ignoring the 90 degree. So anytime I'm using trig, I want to look for a 90 degree angle as well as some other angle, whether or not it's theta or an actual measurement. It just depends on the type of problem. Then I should have 2 pieces of side information. So when it says 2 sides, I should be focusing on a side here and here, or here and here. That's the main difference between when to use Pythagorean theorem versus trig. Being able to look at a problem and know, okay, I should be using SOHCAHTOA, or I should be using Pythagorean theorem. It makes the problems a lot easier to do, especially if you know what method to start with. So coming up with a game plan is the most important. It is also really important that we know the fractions. So I wrote SOHCAHTOA up here, but let's go ahead and review them one more time. Sines fraction is O over H. Cosines fraction is A over H. And tangents fraction is O over A. So remember, SOHCAHTOA is only useful if you remember how to spell it. Okay? And the spellings have to make sense. If you don't spell it right, you set up your fraction wrong. So the trick with SOHCAHTOA, it's got to be a 90 degree angle. It has to be a right triangle. Okay? It's different from Pythagorean theorem because Pythagorean theorem, I don't know any side information. Half the battle with these problems is making sure that you can identify the correct method. Okay. Next, we move on to law of sines and law of cosines. Now, the law of sines and the law of cosines, let me move that up for you so you can see it. The law of sines and the law of cosines, it depends on what kind of triangle you have. So when I use the law of sines versus the law of cosines, it is not a right triangle. That's important. You don't want to waste your time trying to do SOHCAHTOA if it's not possible to do. So law of sines, law of cosines, those are for not right triangles. The clue for law of sines is that you have 2 angles and 2 sides. So the trick to law of sines is that you have 2 angles and 2 sides. So again, for our angle part, they may or may not be across, but I have to have 2 angles. I also have to have 2 sides. So a side here and here, here and here. And these are just examples. Remember, it's not a right triangle. You have to have two angles. You have to have two sides. As far as the equation goes for law of sines, remember it's sine of capital A over little a equals sine of capital B over little b. The law of sines is a proportion. That's why you have to have two angles and two sides. Since it's a proportion, you have to have two angles and two sides to balance out the proportion. Now, the law of cosines is different. In order to recognize the law of cosines, you have to have one angle and three sides. So one angle is the goal for law of cosines, and remember, these are not right triangles. And then you should know information about all three of your sides. Whether or not those sides are variables doesn't matter. I know information about three sides and one angle. For the law of cosine, that's the one that's got that really long equation. It's c squared equals a squared plus b squared minus 2ab times cosine of capital C. So it's got a really long formula. Remember, the a, b, c, that's all arbitrary. It just helps you set up the formula. The goal is just to be able to identify the differences between these all these different trig possibilities. The very last one is the special right triangles, which is the one we learned yesterday. So the last little piece to this puzzle is when to use 45, 45, 90 and when to use 30, 60, 90. Now, 45, 45, 90 and 30, 60, 90, those are special right triangles. So again, these have to be right triangles. You can't use 30, 60, 90 or 45, 45, 90 if the triangles are not right triangles. Okay. Remember, when you set up across the angles on a 45, 45, 90, we label those legs, L's. Across the 90, we label as H, hypotenuse. Just be mindful of labeling. The legs are created by making the 90-degree angle, and our equation is the hypotenuse equals the leg times square root 2. It's the only formula you need. Next, we have 30, 60, 90. Across the 30, we call it short leg. Across the 60, we call it long leg. And across the H is hypotenuse. On these, you have two different formulas. Long leg equals the short leg times the square root of 3. And the hypotenuse equals the short leg times 2. So just remember, when we're identifying, yes, on special right triangles, if all else fails, you can use SOHCAHTOA. It will work. But you'll have to change all of your answer choices to decimals because your answer choices are going to have square roots in them. Okay? So the whole goal of just this front worksheet is just for us to make sure we know the differences between all of the potential methods you'll see.